Welcome to Chapter 7. In this video, we explore the normal distribution, the most important continuous distribution in statistics. The normal distribution is the most common continuous distribution in statistics. First described by de Moivre in 1733, it models many natural phenomena. More importantly, it describes the behavior of sample means, which makes it the foundation of statistical inference. The normal distribution is recognized by its familiar bell shape. It is a smooth, continuous curve that rises to a peak at the center. The peak occurs at the mean, mu. The curve is perfectly symmetric around mu, meaning the left and right halves are mirror images of each other. The total area under the curve equals exactly 1. Normal distributions form a family defined by two parameters. The first parameter is the mean, mu, which controls the location. Here is a normal curve centered at mu equals -2. Here is one at mu equals 0. And here is one at mu equals 3. All three have the same shape and spread, only their position differs. The second parameter is sigma, the standard deviation, which controls the spread. A small sigma of 0.5 gives a tall, narrow curve. Sigma equals 1 is the standard normal, and sigma equals 2 gives a wider, flatter curve. Larger sigma means more spread, lower peak, but the total area always remains 1. One of the most useful properties of the normal distribution is the 60, 890, 599, 7 rule. Let me set up the axes and draw the curve. About 68% of the area falls within one standard deviation of the mean. About 95% falls within two standard deviations. And 99.7%, essentially all the data, falls within 3 standard deviations. This rule gives us a quick way to assess how unusual any observation is. Let's see a real-world example. Wechsler adult intelligence scores follow a normal distribution with mu equals 100 and sigma equals 15. Here is the bell curve for IQ scores. Applying the 68% rule, 68% of scores fall between 85 and 115, that is, within one standard deviation of the mean. And 95% fall between 70 and 130, within 2 standard deviations. A score below 70 or above 130 would be quite unusual, occurring only about 5% of the time. Let's recap. The normal distribution is bell-shaped and symmetric. It is fully described by two parameters, the mean mu for location and sigma for spread. The 60, 890, 599, 7 rule lets us quickly estimate probabilities, and the total area under any normal curve is always 1.